The go gauge should go in freely, and our no-go gauge should stop.
Using checking fixtures to inspect parts is very common in manufacturing plants. Many engineers are fascinated by checking fixtures. Today, I'm visiting Guangzhou Lidi Manufacturing Technology Co. Limited to explore in detail how checking fixtures are developed and manufactured. Many engineers are not very familiar with how checking fixtures are designed. Today, I had the chance to visit Lidi Manufacturing. Mr. Wu invited me to tour their facility and introduce how checking fixtures are designed and built. Mr. Wu from Lidi gave me a warm welcome and introduced the company's manufacturing capabilities and equipment. Mr. Wu arranged for their chief engineer, Mr. Chen, to accompany me throughout the entire visit and provide a detailed introduction to the checking fixture manufacturing process. Hey Mr. Chen, do you have a dedicated team for checking fixture design?
Yes, of course, our team is here.
That's great. Let's have a look. Mr. Chen, could you give us an overview of your checking fixture design and manufacturing process? Mr. Chen explained that, after receiving the customer's drawings, their team first performs a drawing review, followed by technical discussions with the customer to clarify the design intent and the actual inspection requirements. Then, the team creates a preliminary 3D design for customer confirmation. After the design is approved, they proceed with detailed design work and generate the 2D drawings. Only then do they proceed with component machining, inspection, fixture assembly, and debugging, followed by final overall measurement. After everything is verified and approved, the checking fixture can be delivered to the customer. We know that when designing a checking fixture, several types of critical features are especially important. One category is locating features, which correspond to datum features on the checking fixture, such as the locating surface, primary locating pin, and secondary locating pin. Another category is inspection features, which are used to inspect the geometric tolerances of the measured features, such as the inspection pins shown here and here. Another category is guiding features, such as the guiding sections shown here and here. While reviewing these key checking fixture features with Mr. Chen one by one, such as the flatness of the datum surface, the positional tolerances of the primary and secondary locating pins, the clearance fit of the guide sections, as well as their surface roughness and hardness, he explained that they strictly apply the principles I had previously trained them on in their design practice, which I was very satisfied to hear. We all know that the accuracy requirements for critical features on checking fixtures are very high, typically about 1/10 of the part tolerance. Accordingly, the requirements for machining equipment are also extremely stringent. Mr. Chen then led me to tour some of their machining equipment, in addition to conventional machining centers. Their coordinate grinding machines are capable of achieving extremely high precision in both hole diameter and positional accuracy. This is a coordinate grinding machine. Mr. Chen explained that their coordinate grinders can achieve an accuracy of around 10 microns. Similarly, manufacturing checking fixtures requires not only high-precision machining equipment, but also advanced inspection equipment. Mr. Chen introduced their coordinate measuring machines, pneumatic height gauges, and length measuring instruments.
There's another CMM here as well, which means our inspection equipment setup is relatively complete.
Mr. Chen, I have a question. The diameter tolerances of these gauge pins are extremely tight, even down to the micron level. How do you verify their dimensional accuracy? You're not checking them with a caliper, right?
No, we use a dedicated length measuring machine.
Compared with a caliper, the length measuring instrument offers significantly higher accuracy. Judging from the display, its resolution can reach 0.1 microns. So a caliper isn't accurate enough for this kind of inspection. You need to use a length measuring instrument to measure it, right?
That's right.
So, in simple terms, can a length measuring instrument be understood as a far more accurate caliper?
Yes.
What about the height dimension? That's also very important.
For height measurement, we use a height gauge. This is a pneumatic height gauge. It uses an air-bearing system and is specifically designed for precise height measurement.
Oh, so this is specifically used for height measurement. What level of accuracy can it typically achieve?
It can also reach micron-level accuracy.
Oh, it's micron level as well. After the fixture components are machined and fully inspected, the next stage is checking fixture assembly and tryouts. The datum blocks on the checking fixture are used to establish the coordinate system. After aligning the fixture datums with the datums of the 3D CAD model, the actual components are compared with the CAD data. Adjustments and verification are performed simultaneously until the required fixture accuracy is achieved. The remaining detail work and final finishing are then completed. Once the checking fixture is finalized, it can be used for part inspection. Let's go through the inspection process again. This is datum A, this is B, and this is C. During inspection, the part is loaded onto the checking fixture and fully seated against the datums. It is then securely clamped using the quick action clamps on both sides, ensuring the part is properly located. Next, we check the positional tolerances of these holes. To verify whether the hole locations are within spec, we insert the inspection pins into the holes. If the pin can enter smoothly, the feature is considered acceptable. The same applies here. If the inspection pin fits properly, the positional tolerance passes inspection. This hole passes as well, and the other holes are checked in the same way. It looks like this part should be fully qualified, right? Checking fixtures allow parts to be inspected much faster than with a traditional CMM, which is why they are so widely used in high-volume manufacturing. Well, Mr. Wu, I've just visited your facility and gone through your entire checking fixture process from design and manufacturing to machining and inspection. It's clear that your company has very solid experience and a very mature workflow across all stages. Could you briefly introduce your company to us?
Well, our technical team originally comes from the Guangdong Institute of Mechanical Research. Over the years, we've accumulated extensive experience in checking fixtures, covering design, manufacturing, inspection, and service. We always welcome everyone to visit us and exchange ideas.
Thank you for sharing with us.
Thank you as well.
So far, we've gained a general understanding of how checking fixtures are made. Besides requiring high-precision machining and inspection equipment, fixture manufacturing also demands strong theoretical knowledge from the design engineers. In the next video, we'll dive deeper into the detailed design of checking fixtures. Follow me and improve a little more with every video.